Hello everyone. Today we'll be talking about energy consumption in financial systems. Specifically, we'll be comparing the energy consumption of cryptocurrencies to that of traditional banking. It's important to understand the environmental impact of financial systems, as the energy usage of these systems can have a significant effect on the planet. Traditional banking systems use a lot of energy. This includes the energy usage of bank branches and offices, ATM machines, and data centers and servers used by banks. Additionally, the commuting and transportation of employees also contributes to energy consumption. Now let's talk about the energy consumption of cryptocurrencies, starting with Bitcoin. Bitcoin's energy-intensive proof-of-work (POW) consensus mechanism requires a lot of energy for mining. Estimates suggest that Bitcoin mining uses a significant amount of energy, with some even comparing it to the energy usage of entire countries. Next up is Ethereum, which is in the process of transitioning to a less energy-intensive proof-of-stake (POS) consensus mechanism. While this transition will significantly reduce Ethereum's energy consumption, the current POW mechanism still requires a considerable amount of energy. Moving on to other cryptocurrencies, Binance Coin, Cardano, Dogecoin, XRP, Solana, and Polkadot all have different consensus mechanisms that use varying levels of energy. While some are more energy efficient than others, they all still consume energy. Avalanche uses an energy-efficient consensus mechanism called Avalanche X, which significantly reduces energy consumption compared to other cryptocurrencies. While estimates energy consumption of traditional banking is a topic that is not often discussed, but it is an important factor to consider when analyzing the overall environmental impact of financial systems. Traditional banking involves a variety of activities and infrastructure that require significant energy consumption. First, bank branches and offices require electricity for lighting, heating, and cooling. Additionally, they require equipment such as computers, printers, and other electronic devices, which consume energy during operation. The energy consumption of a bank branch or office will depend on factors such as the size of the building and the number of employees working there. Second, ATM machines require electricity to operate, including lighting and heating, cooling systems, as well as the energy needed to power the machines themselves. The energy consumption of an ATM machine will depend on factors such as the age and model of the machine, as well as its usage patterns. Third, commuting and transportation for employees can also contribute to energy consumption. Employees may drive or use public transportation to get to work, which can consume significant amounts of energy depending on the distance and mode of transportation used. Fourth, data centers and servers used by banks also require significant amounts of energy. These data centers are used to store and process large amounts of data, which require a lot of computing power and energy consumption. Overall, the energy consumption of traditional banking is significant and should not be overlooked when considering the environmental impact of financial systems. Bitcoin is the original cryptocurrency and is often cited as the most energy-intensive due to its proof-of-work consensus mechanism. This mechanism involves solving complex mathematical problems to validate transactions and create new blocks in the blockchain. While this process ensures the security and immutability of the network, it also requires a significant amount of computational power and energy. In fact, estimates suggest that the energy consumption of Bitcoin mining is comparable to that of small countries such as Switzerland or Argentina. The exact figures are difficult to determine, as it depends on factors such as the price of electricity and the efficiency of mining hardware, but it is clear that the energy usage is significant. Some have criticized Bitcoin for its environmental impact, arguing that the energy consumption is not sustainable and contributes to climate change. However, it's important to note that the energy used by Bitcoin mining is often sourced from renewable sources such as hydropower or solar, as these sources are often more cost-effective in remote locations where mining is prevalent. Despite the energy-intensive nature of Bitcoin mining, it's worth noting that the technology has the potential to contribute to a more sustainable future. For example, Bitcoin can facilitate peer-to-peer transactions without the need for intermediaries, which can reduce energy consumption and costs associated with traditional banking systems. In conclusion, while Bitcoin's energy consumption may be a concern for some, it's important to recognize the potential benefits of cryptocurrencies and blockchain technology in creating more efficient and sustainable financial systems. Ethereum is the second largest cryptocurrency by market capitalization after Bitcoin. Unlike Bitcoin, Ethereum is not solely a digital currency, but a decentralized platform that enables the creation of smart contracts and decentralized applications, dApps. Ethereum currently uses a proof-of-work (POW) consensus mechanism, similar to Bitcoin, which requires a significant amount of computational power to secure the network and validate transactions. As the Ethereum network has grown, so has its energy consumption. In 2021, it was estimated that Ethereum's energy consumption was equivalent to that of a small country, with estimates ranging from 44 to 100 terawatt-hours per year. This energy consumption primarily comes from the mining process, where powerful computers solve complex mathematical problems to validate transactions and earn new coins as a reward. However, Ethereum is currently in the process of transitioning to a proof-of-stake (POS) consensus mechanism, which is expected to significantly reduce its energy consumption. POS requires validators to hold a certain amount of cryptocurrency as a stake in the network, rather than relying on computational power. This means that energy consumption is significantly reduced as there is no longer a need for energy-intensive mining operations. While the transition to POS is still ongoing, estimates suggest that Ethereum's energy consumption could be reduced by up to 99% once fully implemented. This would significantly reduce Ethereum's environmental impact and make it a more sustainable option for decentralized applications and smart contracts. In comparison to traditional banking, the energy consumption of Ethereum is still relatively low. In this section, we'll be discussing the energy consumption of some of the top cryptocurrencies, including Binance Coin, BNB, Cardano, ADA, Dogecoin, Doge, XRP, Solana, Sol, Polkadot, DOT, and Avalanche, AVAX. Binance Coin, BNB, uses the proof-of-stake (POS) consensus mechanism, which requires much less energy than proof-of-work (POW) mechanisms like Bitcoin. While exact energy consumption numbers for Binance Coin are not available, it is likely to be much lower than traditional banking. Cardano, ADA, also uses a POS consensus mechanism, making it much more energy efficient than POW cryptocurrencies like Bitcoin. According to a recent report, Cardano's energy consumption is estimated to be just 6% of Bitcoin's. Dogecoin, Doge, uses a POW consensus mechanism, similar to Bitcoin. As a result, its energy consumption is also relatively high compared to POS cryptocurrencies. However, because Dogecoin is not as widely used as Bitcoin, its impact on the environment is likely to be lower. XRP uses a consensus mechanism called the XRP Ledger Consensus Protocol, which is not as energy-intensive as POW mechanisms. While specific energy consumption numbers are not available, it is likely to be lower than traditional banking. Solana, Sol, uses a POS consensus mechanism and is known for its high speed and scalability. According to a recent report, Solana's energy consumption is estimated to be around 0.01% of Bitcoin's. Polkadot, DOT, also uses a POS consensus mechanism and is designed to enable interoperability between different blockchains. While exact energy consumption numbers are not available, it is likely to be much lower than traditional banking. Finally, Avalanche, AVAX, uses a consensus mechanism called Avalanche X, which is designed to be highly energy efficient. According to a recent report, Avalanche's energy consumption is estimated to be around 0.3% of Bitcoin's. Overall, while some cryptocurrencies like Bitcoin and Dogecoin have relatively high energy consumption due to their POW consensus mechanisms, others like Binance Coin, Cardano, Solana, Polkadot, and Avalanche use more energy-efficient POS or other consensus mechanisms. Additionally, the energy consumption of cryptocurrencies as a whole is still relatively small compared to traditional banking. However, it is important for the cryptocurrency industry to continue exploring and implementing sustainable solutions to minimize their impact on the environment.